In this video, we present 3 analytical techniques to reinforce your common sense to make better, defensible decisions. At the end of each technique, simply ask yourself, could I have made better, defensible decisions without resorting to analytical techniques such as these? Multi-criteria decision making using the analytic hierarchy process. Most of the decisions we face in the real world are multi-criteria in nature. Typical examples could procurement, recruiting, locating branch officers, etc. The best way to explain this is to consider a hotel chain hiring a business development manager. They identified 6 criteria and 4 candidates. Let us now look at the HP software that we have developed. I have set up the recruiting problem, and when I hit continue, we have the criteria and the candidates that I have already inserted. We move on to the judgment table. The criteria judgment provides pairwise comparison. All you have to do is remember 2 simple questions. Which one? How much? So the first question is, between availability and leadership, which one is important to you? Availability. Then it's asking availability and salary. You might say salary. You proceed with this. When you finish, you simply say okay, and you hit continue. And you're offered the candidate judgment, which is identical to the previous case. On this occasion, you're offered 1 criterion with multiple candidates. Once again, we answered the 2 questions. Which one? How much? Which we say which candidate is more important than the other one, and to what degree. We do this for each criterion. When you finish, press OK, and we are presented the criteria weights and the candidate weights. Once we complete the evaluation, we generate a graph using the chart maker. We see that the optimum decision is Mary. Additionally, we have 6 bands. These are known as the N-1 evaluation. Here we have removed availability. Here we have removed leadership. And here we have removed salary, etc. And if salary is not an issue, so far better candidate. Could you have made better defensible decisions relying on common sense alone? Probably not. Cost-benefit analysis with sub-criteria. This is a very specific application of the HP technique. Let's consider the purchase of a laptop. Here we have the criteria. Here we have the candidates. And we have the sub-criteria information, which appear as data. The first thing we have to do is run the HP evaluation to determine the criteria weights. Make sure you do not use price in the HP evaluation. Now we have the criteria weights. Note it has to add up to 100. The next thing we do is we run the HP evaluation on the sub-criteria and we enter the corresponding weights in these pink cells. Once this is complete, we simply look at our cost-benefit data and plot a graph. This happens automatically within our software. As you can see, the Acer and the Dell are comparable in terms of benefits. Yet, the Acer is significantly cheaper. So it is up to the individual to decide whether to go for the Acer or for the Dell Inspiron. There are a whole host of applications for this type of evaluation, limited only by your imagination. For example, rating agencies, bid evaluations, real estate, managing customers, selecting a consultant, marketing a product. We encourage you to consider using HP with sub-criteria when the consequences of a suboptimal decision is significant. Single criterion decisions with multiple uncertainties using decision trees and D-zone maps. J&J Pharmaceuticals are developing a new drug for the treatment of diabetes, thrombosis, and cholesterol. However, J&J can invest only in one of these projects. The cost of pursuing these products, for the preliminary test, it would spend $2.5 million, and for the FDA approval, there would be a cost of $500,000. The marketing department has arrived at potential revenues from these projects. Here too, there are some uncertainties. There's a potential for high revenue or low revenue. For example, for cholesterol, the high revenue would be $13 million, while the low would be $7 million. Uncertainties facing J&J now. Will the preliminary test be successful? Will the FDA approve the new drugs? Will sales generate the projected revenue? The question for J&J is which product? We can start with a 50-50 assumption for all uncertainties and then study the impact of such assumptions on the final decision. Action plan. First, draw the DT sketch, then develop the Excel model, then plot the D-zone map, and finally study the uncertainties. Here we have the sketch for the decision tree. We have 3 options, and let's focus on thrombosis. If the preliminary tests are successful,
Then we proceed for FDA approval. And if FDA approval is granted, we proceed to market, and there is a potential for high revenue or low revenue. Similarly for the other two projects. Now to step 2, where we build the Excel decision tree, and in this case, it is for the preliminary test. Once we complete the decision tree model, with one click, we can create the D-zone map. The model creates 3 zones for the 3 decisions: thrombosis, cholesterol, and diabetes. The zone in which the red pointer lands is the recommended decision. Here we have 3 axes. One is for diabetes, the next is for cholesterol, and up here is the thrombosis. When I change the probability of success, the decision is thrombosis. If I change the probability of thrombosis success to 70%, again the recommendation is for thrombosis. What is important to notice is the distance of the pointer from these demarcation lines tells you the degree of freedom you have with regard to your assumptions. In this case, when the probability of diabetes success drops below 46%, the decision should be for thrombosis. Zone map such as this gives you tremendous flexibility to understand the sensitivity of your assumptions to the final decision. We repeat the same process for the FDA approval and the projected revenue, and we can see under all 3 scenarios, the recommended decision is to proceed with diabetes project.
Could you have made better defensible decisions relying on common sense alone? Probably not.
A blood test. Your annual physical shows you have high cholesterol. So you ask the doctor, are you certain? And the doctor says, typically, we see 1 in about 1,000 people affected. This test has been around for many years and is 99% accurate in confirming or denying these ailments. Question. What is the likelihood that you have high cholesterol? A, less than 10%. B, about 50%. C, greater than 90%.
Now, 99% accurate means if we conduct 100 tests, 99 of the results would be trustworthy, and we would only have 1 false result, positive or negative. So imagine 100,000 people are tested, and we create a table. Row A is for those who have the ailments, and row B is for those who do not have the ailments. Now, we would expect 100 of these 100,000 people to have the ailments, because it is 1 in 1,000. And hence, 99,900 would not have the ailments. Now, because the test is 99% accurate, we would see 99 positive results and 1 false negative. That is, 1 person who actually has the ailment will be told that he does not have the ailment. Fair enough? Now, of the 99,900 people who do not have the ailment, 1%, unfortunately, would be tested as false positive. That is, they would be told that they actually have the disease when they don't have the disease. And 98,901 people would be told correctly that they do not have the ailments. The tests yield 1,098 positive results. However, only 99 are true positives. What does this tell us? If you are tested positive, even with a 99% reliable test, there is only a 9.2% chance that you have these ailments. Yes, less than 10%. And the doctor wants to put you on medication.
Statisticians refer to this as the base rate influence. This base rate argument is present in many of the decisions that are associated with uncertainties. Don't ignore this. Many real-world problems are based on data with some degree of uncertainty. Thus, we need to be cognizant of the role of probabilities in our decisions. Most of us believe that common sense, logic, experience, intuition, judgment, etc. can solve any problem. This is a very dangerous assumption. Sadly, most doctors are not aware of this. Do take this into consideration before you rush into a medical procedure. There is more to decision making than just common sense, gut feel, and experience.
No way you can address the 3 problems we presented here relying on common sense alone. Beware. Hubris could lead to suboptimal decisions.